Question number 1. Diagram 1 shows a straight line graph y over x again x squared. Express y in terms of x. So in linear law, what is labeled on the y-axis will be the capital Y. And what is labeled on the x-axis will be the capital X. And the number 5 here is the y-intercept, which is the C, with the coordinate of 0, 5. So first, using the two coordinates, we can find the gradient. So m is equal to 5 minus negative 3 over 0 minus 4. This is equal to 8 divided by negative 4, which is equal to negative 2. To form the equation, we're going to use y equal to mx plus c. Substitute the information that we have. We're going to get y over x equal to negative 2x squared plus 5. To let the y as the subject, we're going to move the x to the other side. Therefore, y is equal to negative 2x cubed plus 5x. Question number 2. Diagram 2 shows an arc JL which subtends an angle of 5.02 radian at the center of the circle K. The radius of the circle is 12.5 cm. Finds the area in centimeter square of the minor sector JKL, which is the shaded region here. So for a full circle, 360 degree, this is equal to 2 pi radian. So to find the angle of the minor sector JKL, it will be 2 pi minus 5.02, which is equal to 1.264 radian. Then to find the area of the minor sector JKL, we're going to use the formula 1 over 2 r squared theta. So this is equal to 1 over 2 times 12.5 squared times 1.264, which is equal to 98.75. Question number 3. Given A for 20 lines on the curve y equal to negative 2x squared plus 10x plus 12, finds A the gradient of the tangent to the curve at point A. If we plot the curve, then it will look like this. And let's say the location of point A is here. Then these straight lines will be the tangent to the curve at point A. So first we need to differentiate y in respect to x for the curve. Then dy dx is equal to negative 4x plus 10. To find the gradient of the tangent, we're going to substitute the x coordinates of the points A into the dy dx. So dy dx is equal to negative 4 times 4 plus 10. So this is equal to negative 16 plus 10, which is equal to negative 6. And that will be the gradient of the tangent at point A. Questions B. Finds the equations of normal to the curve at point A. So this purple straight line here will be the normal to the curve at point A. So the normal is perpendicular to the tangent. So when we take the gradient of the tangent, which is negative 6, and we multiply it with the gradient of the normal, it will give us the answer of negative 1. Therefore, the gradient of the normal will be 1 over 6. As the normal passing through the point A, so using the coordinates of the point A as the x1 and y1, we're going to find the equation of normal using this formula. So y minus 20, this is equal to 1 over 6 x minus 4. Therefore, y is equal to 1 over 6x minus 2 over 3. Then move this negative 20 to the other side, it will be plus 20. Then y is equal to 1 over 6x plus 58 over 3. Question number 4. Injek Adi, Puan Balkis, and Injek Chandra are 3 members of the first generations in an organization. The constitution of the organization stipulates that each member needs to recruit 2 new members. Assume that each member has successfully fulfilled the constitutions of the organizations. A. If the total members of the organization exceed 12,000 for the first time in the nth generations, finds the value of n. So this organization starts with 3 members, as each of them needs to recruit 2 new members. So later on, 3 times 2, we're going to have 6 new members. So these 6 members, each of them need to recruit 2 new members. So 6 times 2, we're going to have, later on, 12 new members. And these 12 members need to recruit each 2 new members. So later on, we're going to have 24 new members. So the numbers of the new members here is going to form a geometric progression, with the A is going to be the 3 and the 2 is going to be the common ratio. So the question A is stated the total members exceeds 12,000. So total members, we're going to use the sum formula of the GP. So here Sn exit is more than 12,000. So for the part Sn, the A is going to be 3, so bracket, the R is going to be 2, so 2n minus 1 over 2 minus 1 greater than 12,000. So for the denominator, 2 minus 1 is going to be 1. So next, move the 3 to the other side. It will be 2n minus 1 greater than 12,000 divided by 3, which is going to be 4,000. Next, move the minus 1 to the other side. So 2 to the power of n is greater than 4001. To solve this, we're going to use logarithms. So first, we're going to log both sides with log base 10. Next, using the power law, move the n's to the front. Then, n times log base 10 of 2 is greater than log base 10 of 4001. Then, n is greater than log base 10 of 4001 divided by log base 10 of 2. So n is greater than 11.97. As n here is referred to the number of terms, then n has to be a whole number. So the whole number nearest to greater than 11.97 will be n is equal to 12. Questions B. Hence, finds the difference between the total members of the organizations until the nth generations and the number of members in the nth generations. So in questions A, we already finds that the nth generations is referred to the 12th generations. And in questions A, we already found that the first term A is equal to 3 and the common ratio R is equal to 2. So first, to find the total members of the organizations until the 12th generations, we're going to use the formula sum of geometric progressions. So S12, this is equal to 3 times 2 to the power of 12 minus 1 over 2 minus 1. So the total is equal to 1 to 2 at 5. And to find the number of members in the 12th generation, we're going to use the formula Tn. So T12 is equal to 3 times 2 to the power of 12 minus 1. This is equal to 3 times 2 to the power of 11, which is equal to 6144. To find the difference, it will be 1 to 2 at 5 minus 6144, which is equal to 6141. Questions 5a. Finds the range of value of x for the quadratic inequalities negative x squared less than 1 over 2 times x minus 1. So first, I want to move this 1 over 2 to the left hand side. It will be negative x squared times 2, which is negative 2x squared. So next, I'm going to bring this negative 2x squared to the right hand side, so that the value of a of this quadratic inequalities will become positive 2. So 0 less than positive 2x squared plus x minus 1. This is the same as positive 2x squared plus x minus 1 greater than 0. So next we're going to factorize the quadratic inequalities. So bracket 2x minus 1, x plus 1 greater than 0. So when we let these quadratic inequalities equal to 0, then we can find the root. So x is equal to 1 over 2 or x is equal to negative 1. So to solve these quadratic inequalities, we're going to use the graph method. As these quadratic inequalities is greater than 0, then the range of value of x is determined on the graph above the x-axis. Hence, the range of value of x is less than negative 1 or x is greater than 1 over 2. Questions B. Given ax squared plus bx plus c equal to 0, derive the quadratic formula by using completing the square method. So first, we need to make sure the coefficient for the x squared is equal to 1. Therefore, we're going to divide every term with a. So next, we're going to get x squared plus b over ax plus c over a equal to 0. So next, we're going to move the c over a to the right hand side. It will be negative c over a. So next, on the left hand side, to complete the square, we're going to plus b over a over 2 square. Then on the right hand side, we also need to plus b over a over 2 square so that the equation will be balanced. So for this part, it will be b over 2a square. So now on the left hand side, we can factorize it. It will be bracket x plus b over 2a square. And on the right hand side, after we expand this, it will be b square over 4a square. So on the right hand side, to combine this as a single fraction, we need to equalize the denominator. Therefore, we need to multiply it by 4a. So on the right hand side, if we arrange this, we're going to get b square minus 4ac over 4a square. So next, we want to move the square to the other side. It will be plus minus square root b square minus 4ac over 4a square. The square root for the 4a square will be 2a. Then this will be plus minus square root b square minus 4ac over 2a. Next, move the b over 2a to the right hand side. It will be minus b over 2a. As both of the fractions on the right hand side are having the same denominator, then we can combine this. And if we rearrange the minus b to the front, then we're going to get negative b plus minus square root b square minus 4ac over 2a. And that will be the quadratic formula. Questions number 6. Diagram 3 shows triangle AOB and segment PQR inscribed in sector POR with center O. A shows that the angle AOB is equal to 0.963 radian. So the angle AOB is located here. The triangle AOB is a right angle triangle. This 7 meter is opposite the 90 degree here, so this is going to be the hypotenuse. And the 4 meter here is the adjacent side. As we know the adjacent and the hypotenuse, then we can find the angle using cos. So cos angle AOB, this will equal to 4 over 7. Then the angle AOB will be 55.15 degree. To convert this into radian, we're going to multiply by 3.142 over 180 degree, which is equal to 0.963 radian. Questions B. Given the perimeter of segment PQR is less than the perimeter of the triangle AOB, find the range of the radius of the sector. So this will be the segment PQR, which consists of the arc length PQR and the chord PR. To find the arc length PQR, we're going to use the formula S equal to R theta. Then the arc length PQR will be R times 0.963, which is equal to 0.963 R. To find the length of the chord PR, we're going to use the cosine rule. So here the A will be the chord PR. So PR squared equal to R squared plus R squared minus 2 times R cos 55.15 degree. So next here we're going to have, so R squared plus R squared, we're going to get 2R squared minus, here we're going to get 2R squared times cos 55.15 is equal to 0.5715. And when we multiply 2 with 0.5715, this is equal to 1.143 R squared. The answer of this is 0.857 R squared. So PR is equal to square root of 0.857 R squared, which is equal to 0.9257 R. Then the perimeter of the segment PQR will be 0.963 R plus 0.9257 R, which is equal to 1.8887 R. Next, to find the perimeter of the triangle AOB, we just need to find the length AB. Using the Pythagoras theorems, AB squared plus 4 squared is equal to 7 squared. So AB squared is equal to 7 squared minus 4 squared. So AB is equal to square root of 33. So perimeter of the triangle AOB will be 7 plus 4 plus square root 33, which is equal to 11 plus square root 33. So based on the questions, the perimeter of the segment PQR is less than the perimeter of the triangle AOB, which means 1.8887R is less than 11 plus square root 33. So R is less than 11 plus square root 33 divided by 1.8887. So R is less than 8.866. So based on the length of OR, which is the radius, OB is equal to 7 meter. Therefore, the range of the radius of the sector will be R is greater than 7 but less than 8.866. Questions number 7. Diagram 4 show rhombus of PQR with angle ORQ equal to 60 degree. The diagonals OQ and PR intersect at point N. It's given that OP equal to P, OR equal to R, and the magnitude vector P is equal to 2. A state the magnitude of 3 vector QR. In a rhombus, all sides are having the same length, and the opposite sides are parallel to each other. Therefore, vector PQ will be R and vector RQ will be P. So 3 times vector QR will be 3 times negative vector P. So here the magnitude for the negative P will still be 2. Therefore, the magnitude of the 3QR will be 3 times 2, which is equal to 6. Questions B, expressed in terms of vector P and vector R. Number 1, OQ. This will be the vector OQ. So using triangle law, we can find vector OQ using OP plus PQ. Then vector OQ will be vector P plus vector R. Number 2, vector Rn. So this will be vector Rn. So using triangle law, we can find vector Rn using vector Ro plus On. So the point N here is the midpoint for the diagonal OQ. So here as RO is in the opposite directions of OR, then vector RO will be negative R plus vector ON is half of the vector OQ. So in questions B1, we already define what is vector OQ, which is vector P plus vector R. Expand this, we're going to get 1 over 2 vector P plus 1 over 2 vector R. Next, solve for vector R. Then the answer will be 1 over 2 vector P minus 1 over 2 vector R. Question C. Finds the value of the magnitude vector P minus vector R. So first, let us determine what is vector P minus vector R. So based on the diagram, the vector RQ here is the vector P. And the vector QP will be the negative R. Therefore, using triangle law, vector P minus vector R is vector RP. So based on the questions, we know that the magnitude of P is equal to 2. As the angle ORQ is equal to 60 degrees, the point N is the midpoint for the diagonal RP and also the diagonal of OQ. Therefore, the angle QRN will be 30 degrees. The length Rn is equal to the length of NP. So using the right angle triangle RNQ, we're going to find the length Rn. So the number 2 here will be the hypotenuse, whereas the Rn is going to be the adjacent side. So using cos, so cos 30 degrees is equal to Rn over 2. Then the length of Rn is equal to 2 times cos 30 degrees, which is equal to square root of 3. So Rp is equal to 2 times Rn. Therefore, Rp is equal to 2 times square root of 3, which is equal to 3.464. Therefore, the magnitude of vector P minus vector R is equal to 3.464. Questions at A. Diagram 5 shows 9 letter cards. 3 letter cards are chosen at random. Find the number of ways to choose the card if the 3 cards include 1, exactly 1 letter M and exactly 1 letter A. So this question is about the combination and not permutation, as we just choosing the card and not arranging it. So first, let's say the letter M is the one that we're going to choose first. To guarantee the first letter we're going to choose is going to be M, then we're just going to choose one M from these 2 letter M. Then this will be 2C1. And let's say the second letter we're going to choose is letter A. To guarantee the letter that we're going to choose is going to be A, then we're just going to choose from these 3 letter A. Then this case will be 3C1. So in order to have exactly 1 letter M and exactly 1 letter A, so the last one, we're going to choose one card from the letter C, E, R, and N. So this case will be 4C1. So to find the number of ways, we're going to multiply this. So this is equal to 2 times 3 times 12, which is equal to 24. Questions number 2. At least 1 letter M. So here we're going to have 2 cases. Case number 1 will be we only going to have 1 M out of 3 letter. And case number 2 will be we're going to have 2 letter M out of 3 letter. So for case number 1, to make sure we only have 1 letter M, so we're going to choose 1 M from this 2 letter M. Then this will be 2C1. And for the other 2 letter, we're going to choose 2 letter out of this 7 cards. Then this will be 7C2. So to find the number of way, we're going to multiply this. For case number 2, to make sure we have 2 letter M here, it means we're going to choose 2 letter M from these 2 letter M cards. Then this will be 2C2. And for the third letter, we're going to choose 1 card out of this 7 letter card. Then this will be 7C1. To find the number of way for the case number 2, we're going to multiply this. So to find the total number of way, we're going to plus the number of way for case 1 and case 2. So this is equal to 2 times 21 plus 1 times 7. It will be equal to 42 plus 7, which is 49. Questions B. Diagram 6 shows 12 car parking spaces in an area. There are 3 cars need to be parked randomly in that area. Find the number of possible arrangement of the car if, number 1, there is no restrictions. This means the 3 cars can be parked in any of the 12 cars parking spaces. Therefore, the number of possible arrangement will be 12p3, which is equal to 1320. Question number 2. None of the cars are parked next to each other. So there are 2 scenarios for none of the cars are parked next to each other. For scenario number 1, we are going to look at these 3 parking as 1. Then in total, we're going to have 4 parking slots. So now if we park these 3 cars, let's say we label the car here as car A, B, and C, into one of these 4 parking slots, then definitely none of the cars are parked next to each other. So here we're going to arrange 3 cars into 4 parking slots. So the arrangement will be 4p3. So now let's say we arrange the car A into the parking lot number 1. The car A can be parked here in the middle or on the right hand side. So here the arrangement for the car A will be 3p1. So we're going to multiply this with 3p1. Then for car B and C, the same arrangement will apply. Then we're going to multiply 3p1 for car B and 3p1 for car C. So the arrangement for the scenario number 1 will be 648. For scenario number 2, we're still going to look at these 3 parking lots as 1. So let's say in this parking lot number 1, there are 2 cars arranged in it. So in order these 2 cars are not parked next to each other, then they can only park at the side here. So first we're going to choose 2 cars to be parked in the parking lot number 1. So this will be 3C2. This 3C2 is referred to either car AB, car AC, or car BC that will be chosen. So let's say the combination chosen here will be the car AB. To arrange the car AB into the parking lot number 1, it can be here AB or BA. So there will be 2 ways to arrange the car AB. So 3C2 later on will times 2. So now how about the third car? In this case will be the car C. So the car C, we can arrange it in one of the parking lot that we have here. Then the arrangement for car C will be 9p1. Then these 3 cars will not park next to each other. So now let's say the parking lot number 2 will be the parking lot with 2 cars. Then the arrangement will be the same as the case before. We're going to choose 2 cars to be placed in parking lot number 2 and arrange it with 2 arrangement. Then the third car can be arranged in one of the 9 parking lot here. As this case is the same as the case before, then the arrangement will be 3C2 times 2 times 9P1. So now let's say the parking lot number 3 is the parking lot with 2 cars. Then the same arrangement will apply again. So in total, there are 4 arrangements of 3C2 times 2 times 9P1. So we're going to multiply this arrangement with 4, which is equal to 216. So the total number of possible arrangement of the car that none of the car are parked next to each other, this will be 648 plus 216, which is equal to 864. Questions number 9. Diagram 7 shows the curve y equal to gx intersect the x-axis at point A, origin, and point B. Given the gradient functions of the curve is negative 3x squared minus 2x plus 2, finds A the equations of the curve. So the gradient functions here is referred to the dy dx. To find the equation of the curve, then we're going to integrate the gradient functions. So equation, let's say we use y. So y, we integrate negative 3x squared minus 2x plus 2 in respect to x. Then y is equal to negative 3x, the power you're going to plus 1, followed by, put down the power, then negative 2x squared over 2 plus 2x plus c. So here we can simplify the number 2 and the 3 here. Then y is equal to negative x cubed minus x squared plus 2x plus c. Now, based on the diagram, here the y-intercept is equal to 0. So when c is equal to 0, then the equations of the curve will be y equal to negative x cubed minus x squared plus 2x. Questions B. Finds the area of the shaded region. So first we're going to find the value of AB so that we can have the upper limit and the lower limit. So AB is the root for the equations. To find the root, we're going to let the equations of the curve in questions A equal to 0. To factorize this, I'm going to let the x cubed as the positive 1. So we're going to divide every term with negative 1. Then we're going to get x cubed plus x squared minus 2x is equal to 0. So all these terms have x as the common factor. So we can first take the x to the front. So bracket x squared plus x minus 2 equal to 0. So for the part in the bracket, we can factorize it further. It will be x minus 1, x plus 2 equal to 0. So we're going to get 3 roots. The first one is x equal to 0, followed by x equal to 1 or x equal to negative 2. So based on the diagram, B will be 1 and A will be the negative 2, and the 0 is referred to the y-intercept here. To find the area, we're going to integrate this separately, as one of the shaded region is below the x-axis and the other one is above the x-axis. So let's say I label this as part A and this as part B. So for area A, this is equal to, we're going to integrate from 0 to negative 2 of negative x cubed minus x squared plus 2x in respect to x. So this is equal to negative x to the power of 4 over 4 minus x cubed over 3 plus 2x squared over 2. So the number 2 here, we can simplify it. Next, we're going to substitute the upper limit and lower limit into the equations. So this will equal to 0 minus 8 over 3, which is equal to negative 8 over 3. We get the negative answer as the shaded region is below the x-axis, but area must be a positive. So we're going to put a modulus sign here. So the area A is equal to 8 over 3. So for area B, we want to integrate from 1 to 0. So this is equal to. So next, we want to substitute the upper limit and lower limit. So this is equal to 5 over 12 minus 0, which is equal to 5 over 12. Then the area of the shaded region will be 8 over 3 plus 5 over 12, which is equal to 37 over 12. Questions number 10. Diagram 8 shows a line segment PQ. A. It is given that point S lies on the line segment PQ such that its distance from point P is 75% of length PQ. Finds the coordinates of S. So if S from P is 75% of PQ, then S to Q will be 25%. So if we convert this percentage in the form of ratio of PS to SQ, this is equal to 75 to 25. So if we simplify this by dividing every terms with 25, then we're going to get 3 to 1. So to find the coordinate S as the divisor, it will be 3 times 8 plus 1 times negative 4 and divide by the total ratio, which is 3 plus 1. This is for the x coordinate of S. So for the y coordinate of S, it will be 3 times negative 12 plus 1 times 4 divided by 3 plus 1. Then the coordinate of S will be 5 negative 8. Questions B. The shorter distance from point R to the line segment PQ is through point S. Finds the equation of the straight line RS. As RS is the shortest distance to PQ, this means RS is perpendicular to PQ. So first we can find the gradient PQ. It will be 4 minus negative 12 divided by negative 4 minus 8, which is equal to negative 4 over 3. As RS is perpendicular to PQ, which means gradient RS times gradient PQ, which is negative 4 over 3. This is equal to negative 1. Then the gradient RS will equal to positive 3 over 4. So as we know the coordinate of the point S for the straight line RS, we're going to let the coordinate S as the x1, y1. Then to form the equation, it will be y minus negative 8 equal to 3 over 4 x minus 5. So this is equal to y plus 8 equal to 3 over 4x minus 15 over 4. Then y is equal to 3 over 4x minus 15 over 4 minus 8. So y is equal to 3 over 4x minus 47 over 4. Questions 11a. The following is a false statement regarding arithmetic progressions. Arithmetic progressions is a sequence of numbers such that each term is obtained by multiplying a constant to the term before it. Write a true statement for an arithmetic progression by changing only one word from the statement. So the word here will be multiplying. If we're multiplying a constant to the term before it, then we're going to get what we call as the geometric progressions. To form a true statement, we're going to change the word multiplying to the word adding. Questions 11b. Diagram 9 shows a circle that will be divided into 15 sectors to form an arithmetic progression such that theta 1 is less than theta 2. 1. Given that the angle of the largest sector is 38 degrees, Find the sum of the last 5 terms of the progressions. So here the largest sector is referred to the last term, which is the 15th term. Therefore, T15 is equal to 38. So T15 is equal to A plus 15 minus 1D. Therefore, A plus 14D is equal to 38. We cannot solve this equation as we have two unknowns. So we need to find another equation. As this is a circle, then we know that the total angle is equal to 360 degrees. So if we sum up this theta here until the 15 theta, the answer is equal to 360 degrees. Therefore, S15 is equal to 360. So the equations for the S15 will be n over 2. Here will be 15 over 2 times 2a plus 15 minus 1d. This is equal to 360. Move the 15 over 2 to the right hand side. Then we're going to get 2a plus 14d is equal to 48. So let's say we label this as equation 1 and this as equation 2. So when equation 2 minus equation 1, we're going to find that a is equal to 10. Next, we're going to sub a equal to 10 into equations number 1. So 10 plus 14d equal to 38. So 14d will equal to 28 and d is equal to 2. So now, the sum of the last 5 terms. This is equal to T11 plus T12 until T15. This is equal to S15 minus S10. So we know that S15 is equal to 360 degrees. To find S10, it will be 10 over 2, 2 times the A, which is 10, plus 10 minus 1, the D, which is equal to 2. This is equal to 360 minus 190. So the answer is equal to 170. Questions B2. There are other ways to divide the circle into 15 sectors. Find all the combinations of the first term A and the common difference D such that A and D are positive integers. In questions B1, the total of the 15 sectors is equal to 360 degrees. So after we simplify these equations, it will be A plus 7D equal to 24. In questions B1, the circle is divided into 15 sectors with the A equal to 10 and D equal to 2. So for the other ways, as A and D are positive integers, which means they are greater than 0, starting from number 1. So based on the equation A plus 7D equal to 24, the value D here has to be in between 1 to 3. As 7 times 4 is equal to 28. Then the value on the left hand side is greater than the value on the right hand side. Then A will become a negative. In B1, as D equal to 2 has been used, then we're going to try with D equal to 1 first. Then A plus 7 times 1 is equal to 24. Then A is equal to 17. In this case, A and D are positive integers. Then when D is equal to 3, A plus 7 times 3 is equal to 24. Then A is equal to 24 minus 21, which is 3. Here the D and A are positive integers. So these 2D and A will be the combinations. Questions number 12. Diagram 10 shows an incomplete graph of xb 3p. A shows that p is equal to 8 times cube root of s. So for the binomial distributions, this number 3 here is referred to the number of trial. and P is the probability of success. To show for questions A, we're going to use these informations. So for this information is the probability for x is equal to 3. The answer is equal to 512s. So now refer to this formula. We can write the px equal to 3 as 3c3 p to the power of 3 q to the power of 0. This is equal to 512s. So here 3c3 and q to the power of 0, this is equal to 1. Then p cubed is equal to 512s. So p is the cube root of 512s. So the cube root for the 512 is equal to 8. So the answer will be 8 times cube root of s. Question B. Finds the value of px equal to 2. To find the value of px equal to 2, we need to know what is the probability of success and the failure. Therefore, first we need to find what is the value of s. In questions 12a, we know that the probability of success p is equal to 8 times cube root of s. To find the probability of failure, then we're going to use these informations. So here when px equal to 0, the answer is 8s. So now refer to the formula. This will be 3c0 p to the power of 0 q to the power of 3. This is equal to 8s. The value of 3c0 and p to the power of 0 is equal to 1. Therefore, cube root is equal to 8s. Then q is equal to cube root of 8s. The cube root of s is equal to 2. So the q is equal to 2 times cube root of s. We know that other information is when we plus p and q, the answer is equal to 1. So 8 times cube root of s plus 2 times cube root of s, this is equal to 1. So on the left hand side, when we sum up, we're going to get 10 to the cube root of s, this is equal to 1. Then cube root of s is equal to 1 over 10. S is equal to 1 over 10 to the power of 3. So s is equal to 0.001. So now the probability of success p is equal to 8 times cube root of 0.001, which is equal to 4 over 5. Then q will be equal to 1 over 5. So now to find the value of p, x equal to 2. This is equal to 3c2 bracket 4 over 5 to the power of 2 times 1 over 5 to the power of 1. So it is equal to 0.384. Questions number 13. Given that gx equal to x plus 4 over 3 and fgx equal to 18 over 17 minus x, x is not equal to k. Finds a1 the value of k. So here we need to refer to the denominator of the function fg. The denominator cannot be equal to 0. Because when the denominator is equal to 0, the function fg is undefined. So here, the value of x that will cause the denominator to become 0 is 17. As 17 minus 17 is equal to 0. So here the x is not equal to 17. Therefore, when we make comparisons, k is equal to 17. Number 2, g5. So here number 5 is the input. So it will equal to 5 plus 4 divided by 3. So this is 9 over 3. So the answer is 3. Number 3, the value of x when gx maps onto itself. This means if we put in the value of x into the function g, what we're going to get is the x. So what we're going to get next is x plus 4 over 3 equal to x. So x plus 4 will equal to 3x. So combine all the x on one side. So 3x minus x, we're going to get 2x equal to 4. Then x is equal to 2. This means if you input number 2 into the function g, you will get back number 2. Questions B. Find fx in terms of x. In this case, to find the function fx, we are going to input the inverse g into the composite function fg. So first, let us find the inverse function of g. So first, we're going to let the function gx equal to y. So x plus 4 over 3 equal to y. To find the inverse, we're going to let x to become the subject. So x plus 4 equal to 3y. Next, x is equal to 3y minus 4. Then, the inverse g of y is equal to 3y minus 4. The inverse g of x will be 3x minus 4. So next, we're going to input the inverse g, 3x minus 4, into the composite function fg, into the x here. This is equal to 18 over 17 minus 3x minus 4. So this is equal to 18 over 21 minus 3x. So for the denominator, we have common factor of 3. Then this is equal to 18 over 3 bracket 7 minus x. So the 3 and the 18, we can simplify it. Then fx is equal to 6 over 7 minus x. Question C. Hence, by using composite functions, verify that hx equal to 7 minus 6 over x is the inverse function of fx. So function h and f are inverse of each other if and only if the composite function of hf, the answer is equal to x, or fh, the answer is equal to x. So first, let us use hf. We are going to input the function f into the function h at the x here. We're going to get 7 minus 6 over 6 over 7 minus x. So for this part, this is equal to 6 times 7 minus x over 6. So here we can cancel the 6. Next, we're going to get 7 minus 7 plus x. Then the answer is equal to x. Or you can use the composite function fh. Here, we're going to input the function h into the function f at the x here. This is equal to 6 over 7 minus bracket 7 minus 6 over x. So this is equal to 6 over 7 minus 7 plus 6 over x. So here 7 minus 7 is equal to 0. Then this will be 6 over 6 over x. This is equal to 6 times x over 6. So cancel the 6, the answer is equal to x. As the answer for both composite function is equal to x, then function h is the inverse of f. Questions 14a. A cylinder has a radius of 1 over square root 3 plus 1 centimeter and a height of square root 3 minus 1 centimeter. Find the volume of the cylinder in the form of a plus b square root 3 pi centimeter cube such that a and b are constants. The formula to find volume of cylinder is pi r square h. So this will equal to pi bracket 1 over square root 3 plus 1 square times square root 3 minus 1. So first, we're going to expand for this part. This is equal to pi bracket 1 over 3 plus 2 sec 3 plus 1. So next, multiply the two brackets together. We're going to get square root 3 minus 1 over 4 plus 2 sub 3. So to rationalize the denominator, we need to multiply with conjugate surd. In this case will be 4 minus 2 sub 3 over 4 minus 2 sub 3. Expand this, then we're going to get pi bracket 4 sub 3 minus 6 minus 4 plus 2 sub 3 over 16 minus 12. This is equal to pi bracket negative 10 plus 6 sub 3 over 4. So this is equal to bracket negative 10 over 4 plus 6 sub 3 over 4 times pi. Simplify this, you're going to get negative 5 over 2 plus 3 over 2 sub 3 pi. Then we already write the volume of cylinder in the form of A plus B sub 3 pi. Questions B. Table 1 shows the number of populations in a country. Population's growth rates R in a country can be represented by R equal to 1 over N ln Pn over Po, such that Pn is the number of populations in the current year, Po is the number of population in the base year, and N is the number of years. Find the growth rates in percentage for the year 2022. So here the year 2022 will be the current year. Then this population here will be the Pn. Then the best year will be the year 2020. Then this information here is the PO. So here the number of years from 2020 to 2022 will be 2. So next we're going to substitute all the informations into the equation. So it will be 1 over 2 ln. So here using calculator, the answer of R is 0.01043. So the questions want the growth rate in percentage. Then we're going to multiply the 0.01043 by 100. Then R is equal to 1.043%. Question C. Diagram 11 shows Vanessa and husband who are holding placards. Whose statement is true? Give your justifications by using the law of indices. So here we want to determine 5 to the power of 300 and 3 to the power of 500, which one is bigger. So noted that the power 300 and 500, they have the common factor of 100. So 5 to the power of 300, we can write this as 5 to the power of 3 times 100. And 3 to the power of 500, we can write this as 3 to the power of 5 times 100. Now, 5 cubed, this is equal to 125. And 3 to the power of 5, this is equal to 243. So now, the power of these two numbers are the same, but the base 243 is bigger than 125. Therefore, 125 to the power of 100 is less than 243 to the power of 100. Then this means 5 to the power of 300 is less than 3 to the power of 500. Therefore, the statement of Haswan is true. Questions 15a. Solve the equations 21 cos square x equal to sin x plus 16 for x in between 0 to 360. So now refer to the basic identity of sin square x plus cos square x equal to 1. We are going to substitute the cos square x here with 1 minus sin square x. So 21 times 1 minus sin square x. So this is equal to 21 minus 21 times sin square x. So we're going to solve these equations using the quadratic equations method, as the highest power here is 2. To make sure that a is equal to positive, then I'm going to move everything to the right hand side. Then positive 21 square x plus add sines x plus 16 minus 21 is negative 5. This is equal to 0. Factorize this, then you're going to get 3 sines x minus 1 and 7 sines x plus 5 is equal to 0. Therefore, sines x is equal to 1 over 3, or sines x is equal to negative 5 over 7. So for sines x equal to 1 over 3, as 1 over 3 is positive, then the answer here will lies on the quadrant 1 and quadrant number 2. As for sines x equal to negative 5 over 7, then the answer will lies on quadrant number 3 and quadrant number 4. So next, let us find the reference angle for sines x equal to 1 over 3. This is equal to 19.47. So as the answer is lies on quadrant 1 and quadrant number 2, then here will be the 19.47. So here, the answer for the quadrant number 1 will just be 19.47 degree. And for the angle in the second quadrant, it will be 180 degree minus 19.47, which is equal to 160.53. Now for sine x equal to negative 5 over 7, let us find its reference angle, which is equal to 45.58. Then the angle here will be 45.58. So for the angle lines on the third quadrant, it will be 180 degree plus 45.58, which is equal to 225.58. And for the angle lines on the fourth quadrant, it will be 360 degree minus 45.58, which is equal to 314.42. Questions B. Diagram 12 show a vertical clock tower with a height of h meters on a horizontal ground. A spotlight is at point D such that the angle of elevations of D from B is 25 degree. Express tangent 25 in terms of h and P. So based on the angle 50 here, the h will be the opposite side and the P will be the adjacent side. And tangent is equal to the opposite side divided by the adjacent side. So here, the tangent 50 degree is equal to h over p. So now let us refer to the double angle formula for the tangent. So if 2a here is referred to 50 degree, then the a here is half of the 2a. Then the a here is going to be the 25 degree. So next, we can substitute the tangent 50 degree here with h over p. So next, we're going to do cross multiplications. So when p times 2 tangent 25 degree, this is equal to 2p tangent 25 degree equal to h minus h tangent square 25 degree. So now we can treat this as an quadratic equations. So we're going to move everything to the left hand side. Then we're going to get h tangent square 25 degree plus 2p tangent 25 degree minus h. This is equal to 0. So if you change tangent 25 degree as x, then you're going to get hx square plus 2px minus h equal to 0. So now to express tangent 25 in terms of h and p, we are going to use the formula. because we are not able to factorize this. So based on the equations, the A is equal to H, the B is 2P, and C is equal to negative H. So the X here, we're going to replace it as tangent 25 degree. So this is equal to negative 2P plus minus square root B square will be 2P square minus 4A, which is the H, and C is the negative H, over 2 times H. Next, we're going to get negative 2P plus minus square root 4P square plus 4H square over 2H. So based on the diagram, the tangent 25 degree will be the length of CD divided with the length of BC. So the value for the tangent 25 degree will be greater than 0. So now for the tangent 25, we have two answers. One is plus and one is minus the square root B square minus 4AC. So for the answer to be positive, then we're going to take plus. So next, I can write this as negative 2P plus square root. So I can factorize this over 2H. So here the answer for the square root 4 is equal to 2. So next we're going to get negative 2P plus 2 square root P square plus H square over 2H. So here for the number 2, we can simplify this. So finally the answer will be negative P plus square root P square plus H square over H.